Well, our next speaker gives me real pleasure to introduce our next speaker, Bruce Roundy. He's professor of range science, Brigham Young University, Provo. And Bruce is another one of these guys that's been wandering around these neck of the woods here for over 4 decades. And every time I talk to Bruce, I always learn something. So he's just been a great guy to be rubbing shoulders with over those years.
Thanks a lot, Rick. I learn a lot from him too, and it amazes me the perspective that he has. He's not that old, but he has like a million-year perspective on climate. I'm grateful to all the BYU students, grad students, and undergraduates and others, and also my Sage Step colleagues who've contributed to this presentation. I remember Randy Larson, a wildlife biologist in our department. I encountered him in the hall and he said, wow, there's an all-out war on Pinyon Juniper. And, you know, if you drive around the West, you see a lot of Pinyon Juniper control projects. And I've appreciated the perspective we've heard here today about that. What I'm going to do is talk about two studies. I'll mention a few things that Rachel didn't mention about the Sage Step study. And that's 10 sites, and I'll talk a little bit about fuel control response, because the whole idea was to control fuels when we went in and did these treatments. So I'll talk about that, and then I'll also talk a little bit about our subsequent shred study, I call it. We had over 40 sites in Utah where we did a post hoc study of shredding, and we looked at vegetation and soil response on untreated and masticated areas. And then Dr. Anderwood will talk about some of the soil response on those sites. That study would not have been possible without the work of April Hewlett, who not only determined that you could use high resolution imagery to assess fuels from the air, but that you could also go back and get NAPE imagery that was taken before our sites were masticated so that we could determine pre-treatment tree cover. And as you can see or have seen from Rachel's talk, it makes a big difference the stage of tree cover or tree dominance that you treat these sites. The outcomes will vary greatly where you do that. And Rick and Robin Tausch did pioneering work and talking about phase 1, phase 2, phase 3, and what you ought to do at those phases. So I wanted to acknowledge April's work in allowing us to determine pre-treatment tree cover on these sites, that we were then able to match up with untreated sites nearby tree cover-wise so we could still do this analysis of covariance. So you get out there and control these, implement these treatments, and you know, does it really support ecosystem function, as Nicole talked about as that second objective for fuel control? That's really where our money has come for vegetation treatments. And no treatment is a treatment. And you ought to look at the consequences of that. And what you're going to see here is a couple things going on. As you look at tree cover increasing, of course, the big get bigger and the small get smaller. It's classic forest succession where the bigger structure acquires more resources and is able to take away those resources from the smaller structures, and the shrubs and tall grasses especially diminish. The short grasses don't diminish so much, as do the tall grasses and the shrubs that compete more in time and space for those resources with the trees. And this is from actual data. The top graph is Sage Step actual pre-treatment data from many plots, hundreds of plots. The bottom ones are from the shred study, untreated plots, where you can see the herbaceous biomass going down as tree cover increases and shrub biomass also decreasing. So doing nothing is going to end up in a couple of results. You're going to lose your shrubs, eventually lose your tall grasses, and your trees are going to get big and produce a lot of fuel. So then if you take a look, for example, at a 30% pre-treatment tree cover, And if the untreated or cut are going to be the same. You just took the tree and put it on the ground, right? In the first few years before the needles fall off, not much difference. But you have all high fuel size classes, especially the 1 hour and 1,000 hour. No surprise that we get these catastrophic fires in August that burn large acreages. If you shred these trees, you take that 1,000 hour fuel and you put it in the 1 hour and 10 hour categories. Make it much smaller. If you burn, burning is a great way to reduce fuels. I think I learned that on my first Boy Scout camp out. Okay. One of the things you do when you do these fuel control treatments, of course, is you increase the herbaceous fuel loading. So that's going to go up, and especially where the trees were more dominant. If you go in and do subsequent burns, you may control that a little bit, but you will get a change from woody to herbaceous fuel loading when you do mechanical treatments. I mean, from woody to herbaceous. And shrub fuels, of course, are going to depend on the tree cover or tree dominance when you treat, because your shrubs are basically gone when you get over 20-30% tree cover. Okay, but what's really going on here? It's really hard to measure the effect of these treatments on what fire really does. It's not even in the models very well. People are scrambling trying to make those models work for mechanical fuel control treatments. But we had a case study where our Stansbury site had received no treatment, cut and drop, prescribed fire, and mastication. 2 years later, the big pole fire raced through there, burned 45,000 acres in a few days. And we got to see what happened, okay? We had these soil moisture measurement equipment out there, and they became our sensors for determining fire intensity. And what happened is on the prescribed burn, when the big pole fire came through, it burned through there, but very low intensity, and the microloggers are still working out there. However, on the cut and drop and the mastication, batteries welded to the fiberglass enclosures. $40,000 instruments destroyed to show that when you put fuels on the ground and have a subsequent wildfire, you get high fire temperatures. And so that's what happened. So yet there is a reason to do these mechanical treatments. As I've talked to the land managers, Brad Jessup in particular, who took these pictures over here, when you take and drop those canopy fuels to the ground, you can reduce your flame length substantially, and then the suppression crews can get in there and put out that fire, whereas they can't do it with a fire racing through the canopy. So it does allow suppression to do these treatments. However, if you do have post-treatment wildfire, you can end up with quite a bit of loss. This is cover loss on the Stansbury site 1 year after the big pole fire. And if you look at that graph, only the prescribed burn had the least loss. All the mechanical treatments and untreated had quite a bit of cover loss when you have a wildfire on those mechanical treatments. So that's why some agencies are coming in after mechanical treatment and doing spot burns during the cool season to preserve their shrubs and to reduce the fuels. Looking at shredding, because Rachel didn't talk about this, we compared the response of shredding on our 40-plus sites in our shred study with cutting on the 10 sites in the Sage Step study. And in general found that cutting and shredding produced about over the region a similar response. And that response was to maintain the shrubs and improve tall grass cover here. And what really most surprised me about both the studies, the Sage Step and the shred study, is the great response of tall grasses that we got at high tree dominance. We really had those tall grasses come back very well on some sites, or most sites. And backing up what Nicole said, we measured on different sites with our shred study, we measured what happened to cheatgrass when you did shredding. And when you did it at high tree cover, you got a lot of cheatgrass, like she said. But when you had seeding and shredding, or seeding and then shredded afterwards, that really suppressed the cheatgrass, kept it down there at less than 15%. And Kevin will talk about that right there. Also, I wanted to mention something about sagebrush recruitment. This is from the Sage Step study. We noticed an increase in sagebrush seedlings the first few years after treatments. This top graph here to the left is about percent of subplots with sagebrush seedlings. It decreased over time from 3 to 6 years since treatment, but it really decreased in density. And we think that may be because we had most of our years since we started the Sage Step study have been drier than normal, except for the spring of 2011. So sagebrush seedlings are coming back, and we're getting some increase in sagebrush. Interestingly, a very small amount on the burn at 0.6 TDI or greater, but it's slow. So don't expect maybe your sagebrush to come roaring back here. It's going to take a while. If you wait to treat, if you burn, it's going to be a while before that sagebrush comes back very fast. We also found that on our shred study, maybe 60% of the shred plots had sagebrush seedlings, but they had about 3 to 4 times the density of the untreated plots nearby. What about tree recovery? Everybody who's ever mechanically treated PJ knows it comes back. So on the top, again, this is for our Sage Step study. The lighter bars are less than 5 centimeters high. The green bars are more like saplings. We had a high percent of plots in the untreated and the cut plots that had those saplings. But when you look at the density of them, they were much less than the smaller seedling trees. And the burn had less. So the burn, one of the advantages of burning is you're going to have less tree recovery. It'll take longer to recover. For the mechanical, it's just a fact of life. Things are going to come back, but you can control them with fairly inexpensive lopping if you get out a few years afterwards. One of the biggest questions, and a BLM Salt Lake employee shook her finger at me when we were trying to establish the plots on the Oniki site. She said, "Roundy, if you turn this site into cheatgrass, you'll have to fix it." And, she kind of worried me because I wondered, she looked like she was pretty serious. I wasn't sure what the consequences would be. But one of the biggest questions is when we do these field control treatments, are they going to go to cheatgrass? And Nicole has mentioned, and we've shown that seeding will help you there. And, if you have any worry that's going to happen, you might want to seed. Nathan Klein took our shred study, the 40-plus sites, looked at abiotic variables and found that summer temperatures that were higher, longer duration, and had a bigger difference with winter temperatures, those sites were more prone to cheatgrass and also sandier soils. So this kind of supports the work of Miller, Chambers, and Pellant, who say that these mesic soil temperature regimes and aeritic soil moisture regimes tend to have more cheatgrass. If you take, again, a look at our sites, and Rachel showed this, you'll see the Walker Butte site over here, very little cheatgrass before, very little after, 7 Mile over in Nevada, very little before, very little after. Go over here to Stansbury, a little, some before, a lot after, especially on the burn. Scipio, Greenville, we got a lot of cheatgrass after. The other sites were in between, and mainly on the burn plots. We got more cheatgrass than, substantially more than on the cut plots. So I've done some ordination recently, non-metric dimensional scaling. It turned out with our variables that this axis here was perennial herbaceous cover. The y-axis is annual cover, cheatgrass cover. That correlated with the NMS axes quite well. Then we overlaid some of our soil moisture temperature variables on that. And basically what we found is pretty good correlation, maybe 0.5 R values, showing that where we have wetter winters and springs, we tend to get more perennial herbaceous cover. Where we have warmer summers and wet falls, we tend to have more cheatgrass dominance. And I wanted to tease it out a little better than that, so I discovered partition analysis, which allows you to take a dependent variable, and the software, the program, the statistics will split it out based on your independent variables, which were my soil moisture and temperature variables. And this was for the burn plots, and it was not only our woodland sites, but also our sage cheat sites. So what we find here is if you have, and I've kind of diagrammed this out here, where you have late spring is warmer, you tend to have more cheatgrass. And if you take that subpopulation and say where the fall is wetter, that'll even be more. So late spring warmer, wetter fall, and less freezing in the fall, that's where you're going to get a lot of cheatgrass. If you go over here and say, okay, our late spring was cooler, but our fall was warmer, you're going to get more cheatgrass. If late spring was cooler and fall was cooler, also, if it wasn't too cool but wet, you'll still get cheatgrass. So there's these compensating things that go on here that affect where you get more or less cheatgrass, okay? And that, by the way, the model explained about 70% of the variability, R squared of 0.7 or so, for both perennial herbaceous and for cheatgrass. For more perennial herbaceous cover, if you had more consistently wet winters and springs, then you tended to get more perennial herbaceous cover. And if you had cooler falls. So sites that have cooler falls are going to be less prone to cheatgrass, more prone to perennial grass dominance. If you go over here and say, well, we don't have consistently wet winters, but we have wet and warm early springs, we still get pretty good perennial herbaceous cover. So we're teasing these things out, and it's definitely based on your population of sites. It could change if you change that. Why do we get these changes? Dr. Anderud will talk about some of this. Most of it's related to soil water. We have measured soil water potential in what I call the resource growth pool, the upper 30 centimeters where the fight for water and soil nitrogen is greatest. And we've measured that for 10 years after treatment. And these are the additional spring wet days where the soil was wet after treatment in our phase 3 sage step sites or locations within sites. And we're still getting a bonus. 10 years out, we're still getting a bonus of soil moisture taking those trees out. Why is that? Tamsin Stringham and others have shown that you have a lot of interception, can be 20% of these trees intercepting 20% of the precipitation. And you also, they evapotranspire a lot of water. And so you take them out, you're going to have a bonus, and then what's there is going to take advantage of that. So I'm just going to jump to this final recommendation slide. And so, it really does matter when you treat and what you do to treat. If you want to maintain your shrubs, mechanical's recommended, and phase 1 to early phase 2 if you want to keep your shrubs there. If you want to reduce fuels really well, have a wildfire, but then you'll have herbaceous cheatgrass fuels, right? But if you want to do a prescribed fire, do it at phase 1 to minimize cheatgrass so you have your tall grasses left to compete with the cheatgrass. If you want to minimize cheatgrass, use mechanical means because that favors the tall grasses, doesn't set back the tall grasses like fire does, and it allows it to compete with cheatgrass. And then you should seed if you have any concerns. Thank you very much. Two minutes for questions. Yes. If you did that and you originally had, what's that? Oh, okay. He asked if we waited 10 to 15 years after we did our mechanical treatments and then did some burning to reduce the trees. That would certainly reduce the trees. If you had done your original treatment and had a lot of phase 3, you're probably not going to have shrubs there for a long time if you come back with fire. But I think what you're going to get is very much a perennial herbaceous dominated grassland, unless it's a very cheatgrass dominated or prone site, and then you might get a lot of cheatgrass. So a lot of times they're going in with the loppers. Yes, Stan.
You showed where sagebrush recovery was pretty slow. Was that which subspecies of sagebrush was that?
Some of our sites were mountain big sagebrush. Some of them were Wyoming big sagebrush. Gene Chambers shows that both of them will come back really well if you have a seed source nearby, but large plots and large burns don't tend to have a seed source. Yeah. Yes, Tyler. In other words, is the mastication supporting cheatgrass or, okay, oh, okay. So Tyler says they're getting pressure to, after they masticate, to turn that wood into commercial use and remove it. On the Pinyon Juniper sites that we studied, most of it wasn't so high that it inhibited too much growth. You get kind of growth around the halos of the trees. And the main thing that Kurt Young did, because he studied this in detail, is he showed that you get a longer period of soil moisture and nitrogen. So that mulch tends to help and cover the soil, reduce evaporation, moderate soil temperature a little bit. I'm not so sure it would make a big difference. The big difference is taking out the tree. But people coming in and trying to scoop up that mulch will probably compact the soil and cause you a lot of trouble, more than it's worth. That's my opinion. Thank you.